Hi students, welcome back. So we are discussing embedded system design concepts as per the curriculum of module 4, embedded systems. In the previous video we have discussed operational quality attributes of embedded system. So in this video we are trying to look into detail of non-operational quality attributes of embedded systems. So what do you mean by this non-operational quality attributes? We have already seen that attributes are inherent features, and those features which are to be taken care when the system is operational was operational quality attributes. So obviously the attributes which are to be taken care when the system is non-operative will come under non-operational quality attributes. So we need to address these features when the product is not operational, either when the system is down due to some errors, means when the system is breakdown. When the system is breakdown, it is offline, or maybe when it is at different stages of development where the system will not operate. So in either cases we should be able to address these 5 attributes. So the main 5 attributes, non-operational quality attributes of an embedded system are testability and debuggability. They sit together. Then evolvability, portability, time to prototype and market, and the last one is per unit and total cost. Let us see one by one. And the first one is testability. So what does testability say is how easily anyone can test maybe his or her own design, and by which means he or she can test it. So that is the meaning of testability. So any embedded system designed should be tested before it is being marketed, or basically before when it is commercialized. Before being commercialized, it should be tested. So any embedded system designed should be able to test. So how well or how easily one can test is a measurable feature. So when I say testability, it is applicable to both hardware as well as software. So embedded hardware testing basically ensures that peripherals and other hardware functions are in required manner. Okay, but firmware testing or software testing ensures that the firmware is functioning in the expected way. So this is basically about testing. Coming to debugging or debuggability, so it is a means of debugging the product as such for figuring out the probable sources that create unexpected behavior in the total system. So if we connect this to operational attributes, while discussing reliability, while discussing maintainability, and while discussing safety, we have talked about failure of the system. So a failure of, if a system fails or after the system fails, then we should be able to figure out why the system failed. So that is debuggability. It is not only about the failing of the system. If the system behaves unexpectedly also, it was supposed to do some function and it is diverting from that. We don't know the reason. then we should be able to look into the system and understand why it is behaving so. What is the source of, or what is the source of the error, or what is the source that is creating that error? So basically the ability of debugging will have two aspects. Like we have testability for both hardware and software, debuggability also should be for both hardware and software. So there should be hardware level debugging and there should be firmware level debugging. So as you know, hardware debugging will be used for figuring out the issues created by hardware, whereas firmware debugging is employed to figure out the probable errors due to the coding, due to the flaws in the firmware. It can be any. So when a system doesn't behave in an expected way, or when the system fails, then we should be able to figure out whether it is a hardware failure or software failure, and once we have identified, then again we should be able to identify the exact source of that failure, whether it's in hardware or which component. There is a lot of components making the system, so exactly which component failed. Or there will be a lot of lines of code for me controlling the system, so which line of code is creating that behavior, so I should be able to do that. So this becomes a very good attribute to be known for any given embedded system. Next one is evolvability. So evolution is basically a biological term. Okay, so any non-heritable variation comes under evolution. Putting that into engineering terms, putting into an embedded system, evolvability basically refers to the ease with which the embedded system can be modified. In terms of firmware, it is upgradation of the software, for example. Whether your system allows upgradation. For example, your system was using an Android 9 yesterday. Okay, today can I upgrade my system to Android 10? No, my system doesn't support. Okay, done. So it is not an evolvable embedded system. If it is evolvable, then it will allow that. So basically we say an embedded system should be evolvable. It should be able to upgrade the system. The firmware should be upgraded. It should be also able to take advantage of new hardware technologies. That is also required. My system should allow to add new peripherals if possible. Maybe an extra port is available here and there, okay, where I can connect some extra hardware peripherals. So that will help me to increase the features of the system also. So that is basically what you mean by evolvability. So this we take care offline, right? Because when the system is working, I am not worried about this attribute. So if I want to upgrade the software, or if you want to upgrade the hardware, I will be taking out the system, or I will be making the system offline. Then I will be working on it, then putting it back. So that's why it comes in non-operational attribute. Okay. So the next one is portability. So every embedded system, okay, I say a standard embedded system should always be flexible and portable. So flexibility and portability are almost same. Okay, so we can call this attribute as flexibility or portability, doesn't matter. So what does it actually means is it's a measure of system independence. That means the ease with which an embedded product can be ported to a new platform. For example, maybe an embedded system is using Intel as the target processor. Okay, Intel is the target processor. So I want to change it to a different target processor, maybe say ARM Cortex M3 processor. So is it possible to port? The present system working with some processor, Intel processor, now I have to change it to an ARM processor. Is it possible? what I say is a standard embedded system, that possibility should be there. So it's a feature, portability. I should be able to port. So a standard embedded product should be always be flexible and portable. So this portability becomes easier if the firmware is written in some high level language, maybe like C language. Okay, so when you write it in C language, there will be little target processor specific functions. So in such cases, it is very easy to port the firmware for the new processor by replacing those minimum target processor specific functions which will be handled by C language. So that's basically portability attribute. Nice. The next one is time to prototype and market. So time to market is basically the time elapsed between the conceptualization of the product, okay, starting from the idea, okay, to maybe a block diagram or a circuit diagram. From that point to the time at which the product is ready for commercialization or use. So that entire time, it's a long time. That time is known as time to market. It may depend on depending upon the system developed, this time will be huge or maybe less. 3 months, 6 months, 1 year, 2 years, 3 years, depending upon the technology used. So basically, this is a very good or very important significant attribute basically. If you have an idea of a system, then it should be conceptualized and it should be made as a product as soon as possible. You should limit the time to market. So there comes the importance of prototyping. This product prototyping helps a lot in reducing time to market. So whenever we have a product idea, okay, but we don't know the feasibility of the idea. In such cases, so prototyping will give you an informal kind of rapid product development in which the important features of the product will be developed. So the time to prototype is also critical. You cannot take lot of time for prototyping also. So time to prototype also matters. So time to market is one factor and time to prototype is another factor. If the prototype is developed faster, the actual estimated development time can be brought down significantly. So in order to shorten the time to prototype, we will be making use of all possible options like use of the off-shelf components, reusable components. We will be trying to find out the required components from the scraps so that we can reduce the cost also, which is the next attribute which we are going to discuss. So I hope time to market prototype is very clear. And this is also obviously an offline attribute. So the last one, but not the least, as usual, per unit cost and revenue. So as we discussed, the time to prototype should time to prototype or time to market should be kept minimum because it will affect the cost also. So cost is a factor which should be closely monitored by the end user, okay, maybe the client or maybe a normal user like me or you, or maybe an system user and the product manufacturer who is building the product. So this cost will be monitored by both the manufacturer as well as the user. That's why we say cost is very highly sensitive factor, especially for commercial products. So if your system is costly and a similar technology is available in the market, then user will opt for that, not for your product. So your product fails. Whatever the time you have spent from the conceptualization to the market goes in vain if the costing is not proper. So you need a proper market study and cost benefit analysis before taking decision on per unit cost of the embedded product. So this should be done initially itself. So you have an idea, and if you conceptualize it, and when you prototyping itself, your cost is okay, maybe $200 for an unit. You are expecting it to reach the market at $20, and it's already $200 while prototyping, a lot of things remaining, and there is no use of it. Who will buy that product? Nobody is going to buy. So if you put it in the market for $20 itself, in few days, if there is competition in that field, somebody will come up with $18 fellow. Then you may have to reduce the cost. You may incur loss. So all this depends. So proper market study and cost benefit analysis is required. Okay, being said that, every embedded product has a product life cycle, which starts from the design and development phase. It starts from there. Start from that idea conceptualization phase. And I say that it has a product life cycle. A product in the market is not for lifetime. There is a product life cycle. So this can be explained with an example or with the help of a product life cycle curve. We call it as PLC curve. So as you can see, time is taken on the horizontal axis and revenue is taken on the vertical axis. Okay, so the time is expected to be equally divided. May not be true in all the cases, but for our purpose of explanation, we have taken equal time for each phases. Okay, it's an assumption, and revenue is approximately quoted. Okay, time is approximated and revenue is less approximated. Okay, being said that, you look at the first phase. The first phase is the product development phase. In this phase, there is no revenue generated. That is, during the design or development phase, there is only investment, there are no returns. So this phase you will not find any revenue. So as you can see here, if this is the profit line, it's negative side. So we should not talk about profit. It's all investment here. Okay. So then I go to the next stage. That's time to market. This product development phase is actually basically time to market. Now I'll be introducing the product into the market. That is the phase when the product is ready to sell. So once the product is ready to sell, it is introduced to the market. So this stage we will call it as product introduction stage. But at this stage, the unit cost is going to be the best possible cost. And the product sale will be minimum because it's a new product in the market. So people are not ready for it. Your product is ready for the market, but the users are not ready for the product. So initially the sales will be minimum. And obviously the revenue will be low. It will not cover your initial investments. So still your revenue will be in the negative side. Now the next phase is termed as growth phase. So here the product grabs a good amount of market share. At this phase, the unit cost starts reducing slightly, and this is where you start making profit. Because you are producing your product in batches, lot of batches, and there is a good demand in the market, and you are satisfied with your unit cost. So now the sale is increasing. So more number of units are being sold. So now you are on the profit side. So the next phase we call maturity phase, that is product maturity phase. So during this phase, the growth and sales will be expected to be steady, and the revenue is going to reach the peak. As you can see here, the product sale is at the peak, but the unit cost might have been reduced by that time. So the profit will be reduced, okay, but still we are happy because more and more products are being sold. So we can say that it will reduce, it will create the maximum revenue. So the maximum revenue is somewhere here at the end of product maturity phase. Unit cost is less, Okay, profit is comparatively less when you compare to that actual starting of the product maturity phase. That is because of the unit cost. Unit cost reduces. Okay, you have to create more products, you have to manufacture more products, so production cost also increases. So comparing all that, your profit will be somewhere here, but your revenue will be somewhere here. The total turnover will increase. Okay, now coming to the last phase, the retirement phase. So as I told in the previous video and somewhere in this video, we need the product for lifetime, but that is not possible practically. So any product in the market will have all these phases. The only thing is, maybe this growth phase is too long for some product, or maybe this product maturity time is too long. So some products stays in market for so long, then suddenly disappears. Some product comes into market with so much hula, the introduction phase and growth phase will be huge, and the product maturity phase and retirement phase will be like all of a sudden snap. Okay, now coming to product retirement phase. So what is going to happen in this phase? So here the drop in sales volume starts. Everything starts dropping. The market share, volume of sale, okay, everything start dropping. So basically this decline happens very rapidly in embedded system field. This is because you have tight competition from similar product with enhanced features, or maybe the technology has changed, the architecture has evolved, more advanced architecture has come up, so you have to now change your system. Your system is evolvable, I agree, but is not that evolved because the basic architecture remains same. So evolvability is always there in this phase, growth phase, product maturity, because we should not forget about other attributes when we are discussing this. All other attributes comes into picture when we are talking about this in different phases. So evolvability is always there because your product is always there in the market. Growth is happening. Maybe growth has happened because of some update, some upgradation in your system. Sales was so and so, then you upgraded some feature, then suddenly sales increased. That is also possible. Keeping all that in mind, but at some point of time, your product has to retire from the market. So suddenly, a fine day, the manufacturer will announce the discontinuing of the product. So that basically ends here. So the product life cycle ends here. So the product is no more in the market. So one good example which I can give you before ending this video for this unit cost. Okay, why this unit cost is something like this. Take an example of typical example of a smartphone. So when a smartphone is introduced into the market, maybe online, during its launch time, the price is going to be the best price. We call it a high price. That is actually the best unit cost price at that particular point of time for that company. But for us, it is a high price. So during launch time, the price is going to be high, and you are going to get the same model, okay, with a reduced price after 3 or 4 months of its launching. This we can see. Some smartphone which was available at 20,000 during the launch. After 6 months, the same phone, in the name of offer, you are going to get it for 16K or 17K. So maybe at that time the smartphone has crossed the launching phase anyway, then growth phase anyway, and now it is in product maturity phase, where the unit cost will be remarkably reduced. So you should expect for a product retirement phase soon. So I hope these non-operational attributes are very clear, in the sense you could appreciate the necessity of documenting these attributes and why they are mentioned as quality attributes, importance of that. Saying so, thank you for watching this video.